In class, I discussed how to create this dashboard that shows inventory actuals and a forecast of inventory based on a trend using a slope and intercept for data from a pivot table. Then we added slicers so that we can look at the inventory versus forecast for different areas and different products and different teams. We created a seasonality index using a pivot table and added that to the linear trend to get the linear plus seasonality forecast. In this video, I want to now do the same thing for sales to help you with that. Here is the ERP Sim sales data in this table. The first thing we want to do is create seasonality indices. So I'll create a pivot table for that, and then I'll create another pivot table from the same data that forecasts the sales of an item in an area, etc. So we'll go to Insert, Pivot Table, and that's all fine. We're trying to do the seasonality. So this is sales seasons, I'll call it. And what we want are the units sold on days per quarter. The idea being that we want to say that the seasons are the days, and then we're going to average them over the quarters. We could have seasons as quarters, but that doesn't make as much sense in this data set. I want to see the zeros, so that's a right-click value field settings, and I'll eventually get this. Pivot table options for empty cells show 0, and I want to show all the data. So what I'm going to do is create averages for these different seasons, and then I'm going to compare that to the overall average. So I'm going to pause it and type in some things, and I'll come back in a second. Okay, I've done some formatting and added some data here. This grand average is the average of all this data that I have data for. In other words, I didn't include the zeros because we had no sales that day. This is when we were waiting for sales. You can create this. I guess I should have shown that to you. You can go like this, comma, and select multiple data. Oops, hit the wrong parent. Now I want to create the seasonal averages. So this is equal to the average for the first 3 days. Let's just take those. It'll be more accurate. I don't have that much precision, so I'll go here. And then for this one, let's go ahead and include the sales in the first quarter. So there are all the seasonal averages for each day for the 4 quarters. And now I'm interested in the difference between the seasonal averages and the grand average. So I'm going to take the difference of this equals this minus that. And of course I'll need to stick it in place, make that an absolute reference, so that I can do this. And now I see, well, on day 6 we tend to be 141 above average, and on day 5 we tend to be 573 below average. And I will then add these seasonal differences to the linear trend. This information here will become a lookup when I look up the season to add or subtract from the forecast. Add slicers for product, area, and team to the seasonal indices. Now let's go to the data again and create a pivot table that we will use for our trending data, our linear trend plus the seasonality. So this is the sales forecast. Sales forecast sheet. And for this, we want to predict the sales of the units. So there's all sales over all time. And we're interested in the quarter and the day, and we'll add slicers, etc. And we want to not have these subtotals because we're going to do some data analysis for trending over here, and I don't want to include that information. And I should go ahead and include information that has no data in it. And this data, when there is no data, just show a 0. There it is. Now that's the idea. Now what I want to do is take this data and create a linear trend. I want to fit a line to this data. Now I like having these blanks in here because it creates these charts that have these nice blanks that separate each quarter. And I did that manually by creating these days here that I think I'll just copy over. So I'm just going to copy and paste that there. So those are the days. These are my days. And now I want to have a linear forecast. That forecast is going to be based on the day. That's the x. That's the independent variable. And I'm going to forecast the units. So to do that, I'll put this information up here. I need the slope of the line, which is the slope. And I'm going to skip these first few days and start on day 4. So my known y's, that's what we're trying to predict. Those are the known y's. We're trying to predict that information. And these are the x's. Those are the days. So based on the day, I want to predict the units sold. I'm going to use this same data, so I'm going to copy it. I'm going to use that same data for the intercept as well. So there's the slope. Got lots of precision there. And this is the intercept of the line. So I'm doing an equation of a line. This is the intercept, and I'm going to paste those same numbers in there. And that's the intercept. So I'll start here. It doesn't really matter, but I could start here or here. The prediction based on this data is equal to the day times the slope, and since I'm going to pull it down, I better stick that in place, plus the intercept, same thing. And I don't have that much precision. So I can drag this down, and what the heck, these are my predictions down here, so I'll drag all those down. And I don't have any information here, so I'll just delete those for now. I'm going to delete some more also. So that is my forecast based just on a linear trend of the data. And I can get an estimate of how good that fit is by calculating the mean absolute deviation from the actuals, and you should do that for the homework. But now I want to add seasonality to this prediction, to this linear prediction. So I'll say this is the seasonality, or the season index, just to make it clear. And this is going to be that H lookup that I was talking about. What's H lookup? Well, I'm going to look up this day, that season. I'm going to look up that value in this table, which I have over here, there's the table, comma, and I want to return the 1, 2, 3 down, and I want it to be an exact match. So there's the seasonality that I'm going to add to my linear prediction trend. So minus 91 for that, for 1, and make sure that's all right. So I have sales seasons here. I named this table. I named that table sales seasons up here. So it's an absolute reference, and it reads a little bit easier. So that's the basic idea. And now my forecast is equal to this plus the adjustment for the season. So there's enough to get you going, hopefully, and you can complete the rest. Just to show you, so I could drag this down, and I'll get some problems here. It's like, oh, because I'm looking up a season and I did not include the season there, and so now I can look up the season and add it. And these are my forecast. This is this area here is all forecasted. So maybe I could color it differently. And I can compute the MADs, which is the absolute deviations equal to absolute, the difference between this and this. And I want to be able to drag it down, so that's B5. See if I can do the close pairing. So that's the absolute difference. Well, I don't have anything going on. I really shouldn't even include these first 3 days. So that's the general idea. And then you can, what we could do is just delete all those. And then you'll compute the average of all these to see how good the forecast plus seasonality is. And then you'll add a chart, which you should be able to do. And you'll end up with that nice combination of so your final product should look something like this, where you will take these slicers and copy paste them from the inventory sheet, and here's the forecast chart, and you'll have slicers. So here's my sales forecast. If I create a chart, it's nice to have the actuals in a separate area, and so I put them out here, and these actuals are equal to B8. So there are the actuals. So it's just a repeat of the data I already have. I don't have any actuals down there. And the reason I want to do that is when I create charts and then I add slicers, the charts don't work right when you include this data in the pivot table. And if you did it, you'd see what I meant. So I'll add a chart for product, or a slicer for product. In other words, if I was to create a chart that had the forecast here, and I'll include all this forecast data and hold down the control key, and I'll select all that and do insert chart. There's my actuals versus my forecast. Is that right? Oh, that's just the seasonal indices. selected the wrong one. Well, here I'll show you how to fix that real quick. Select data. This series 1 is not that data. It's in column F. So I'll just say F. It's like, oh yeah, that's the right data. And I could also edit this and say this is the forecast and this is the actuals. After you add slicers, it's nice to connect these slicers to this sheet. In other words, if I change this to just show butter, these seasonal indices are still for all products, in all areas, for all teams. So if I choose just one product, this is no longer correct. I need to come over here and go, well, it's yogurt, and come back here. It's like, okay, those are the right indices for that product. Well, you can connect these by right-clicking and choose Pivot Table Connections, and then say, connect that slicer with this Sales Seasons sheet, Pivot Table 2. And now they're connected, and if I do cream, for instance, if I come over here, cream is selected. I don't know if it works backwards. Yeah, it works backwards too. So there's butter, and if I come here, yes, butter is connected. So that makes life a lot easier versus having to go back and forth and back and forth. So you should do that for all these slicers.